Welcome back. This is video number 12, Guidewires. In this proximal LED pre-stent lesion, which Guidewire would you prefer? BMW, soft or choice floppy? And in this CXOM lesion, is it considered a frontline case or is there need for an extra support body guide wire? And these are the points to be discussed. For any operator, the wires used in the Egyptian market within the last few years should be known. And this is the list of wires from the Asahi, Abbott, Tromo, and Boston Scientific companies. CTO wires used with microcatheters are excluded from the list. What is meant by hydrophilicity? If there is a sheet of paper between two fingers, it is easy to describe the texture and consistency of the paper, and the sensation of the withdrawn paper sheet is preserved. Yet, if the paper sheet or the tip of the fingers is wet, the description of the texture and consistency is decreased, and the sensation of its withdrawal is nearly lost. So, with hydrophilic guide wire, there is lost tip sensation, tactile feedback at the expense of control and safety. Dissection and perforation are not sensed. Yet, there is lost friction and slippery tip during passage in the lesion, which allows for better tracking and crossing. This hydrophilicity also allows smooth device delivery. While with non-hydrophilic guide wire, there is good tip sensation, tactile feedback with more safety, yet friction and resistance during passage in the lesions. What is meant by tactile feedback? It is any physical sensation felt through the guide wire's proximal end at the torque device during wire advancement inside the coronary artery. Other factors besides hydrophilicity as wire tip configuration affects the feedback and will be discussed later. The tactile sensation is from the distal end of the tip of the guide wire to navigate and pass the lesion, and also from the body of the tip for passage across the lesion. With experience, it is important to differentiate between resistance sensation and friction sensation. If tactile feedback at the distal end of the tip is lost or late, it may be later than the visual feedback as the body of the guide wire prolapses with loss of performance, or as the distal tip dissects out of the lumen. Coating on the wire is usually over the distal half. Hydrophobic coating, such as silicone or Teflon, repel water as wax, with formation of blood drops on the guide wire, while hydrophilic coating attracts water to create a slippery gel-like surface when wet, with no drop formation. When this coating is dry, it is not hydrophilic and non-slippery. Since sensation and safety is important in the end of the tip and the lubricity is important in its body, a hybrid formula is introduced. So the main categories is non-hydrophilic tip, hydrophilic tip up to polymer coated, hybrid in which the distal half or the end of the tip is less hydrophilic than the rest of the wire, or hybrid in which the end of the tip is more hydrophilic than the rest of the wire, nearly one wire in the market, discussed later in special indication. Hydrophilicity and non-hydrophilicity is a relative term, not absolute. So wires with silicone coating as soft wire is more hydrophobic if compared with Teflon or PTFE coated wires. Usually, several layers may be added on distal half or the tip of the guide wire. For example, a polymer jacket coating usually added on top of hydrophilic coating. In long procedure cases or lesions with severe tortuosity and calcification, the degradation or abrasion of the coating may occur, decreasing wire performance. So a wire with both a polymer jacket and hydrophilic coating with about 70% reduction in wire surface resistance is preferred. The distal inner diameter of the microcatheters, 0.018 to 0.015 inch, is very close to the distal diameter of the guide wires, 0.014 inch. So, with prolonged manipulations, the boundary layer of water can be excluded, leading to paradoxical sticking and locking only managed by system pullback. Hydrophilicity of any guide wire should be known. P means polymer, H hydrophilic, NH non-hydrophilic, S silicon, E extra hydrophilicity, PTFE polytetrafluoroethylene, and the red star means hybrid tip. Regarding tip load, it is measured in grams, which is the opposing weight at which the wire at a certain point bends when pushed against this weight. If the tip load is 1, this means that the wire can endure up to 0.99 gram before bending. Tip load is determined mainly by core material, height with stainless steel, and thickness. Tip load mainly and other factors in wire configuration increase the penetration force. Roughly speaking, it can be sensed and assessed when the guide wire tip is pushed against the tip of the finger. Grading of stiffness could vary between authors. Super soft or extra floppy, soft or floppy, intermediate, stiff, and super stiff. And here is the grading of guide wires in the market with their specific tip load. As you can see, tip load between 1 to 2.5 grams, only Pilot 50 is in this area, with tip load about 1.5. What is meant by flexibility? It is the ability of the wire to flex on its longitudinal axis while maintaining its trackability and torqueability. It is mainly determined by tip load. A more soft or floppy wire means a more flexible wire, and also by tip configuration, which is discussed later. One of the most common questions, which guide wire is safer with less incidence of dissection during passage in a tight subtotal long lesion? Regarding soft guide wire, it has very low possibility of dissection due to low tip load, with a very good tactile feedback and safety due to non-hydrophilicity with silicon. Filter guide wire has a very low possibility of dissection due to low tip load, yet it will be not sensed due to polymer coating. The PT2LS with a high tip load has a high possibility of dissection, and most probably it is not sensed except late due to its high hydrophilicity. Intermediate guide wire with tip load 3 gram is high possibility of dissection, yet it will be easily sensed from the start due to non-hydrophilicity with silicon. With Pilot 50, there is balance between an intermediate increase in tip load with high hydrophilicity as an initial start before escalating to higher tip load guide wires. So, before using any wire, the basic characteristics and other criteria of the wire should be known in order to avoid complications and increase success rate. At least Pilot 50 guide wire should be familiar in the hands of any operator in non-frontline cases. Regarding specific guide wires, BMW high torque guide wire is with the tip load 0.6 and hydrophilic coating. Opposite to most other guide wires, it has nitinol core and shaping ribbon tip configuration. These are discussed later. Other wires of the BMW family may be present. BMW Universal 1 and 2 have a lower tip load, in addition to intermediate polymer sleeve, which adds lubricity not reaching the end of the tip of the wire. while the BMW Elite Guidewire has a higher tip load and the tip configuration is not shaping ribbon, it is core to tip. Soft Guidewire has a tip load 0.7 gram and a non-hydrophilic coating. As most other guide wires, the core is stainless steel with core to tip configuration. Light guide wire was present in the market. It is as the soft guide wire, but only with a lower tip load. Renato Pro Water guide wire, the tip load is 0.8 gram, hybrid hydrophilicity of the tip with the distal 30 millimeter from the tip and is non-hydrophilic coated if compared with the hydrophilic coating of the proximal segment of the tip. Choice Floppy guide wire has tip load 0.75 gram with hybrid hydrophilicity in which the distal 3 cm is uncoated. Back to the cases. In this proximal LED region, which wire would you prefer? The BMW guide wire passed easily through the lesion and was parked easily in the distal LED. And supported the balloon dilatation and stent deployment in the lesion. The purpose of any wire is to pass the lesion, reach the end of the artery and support the device. So there is wide variation of wires since, for example, the characteristics in the wire in order to reach the lesion may not be appropriate to support a stent or a balloon. In frontline cases, it is easy to reach the lesion after a simple 1 or 2 curves, easy to pass the lesion which is not tight nor long, not bifurcating and with no visible calcium, easy to park the wire distally with good support to the standard devices. So a wire with no special criteria as tapering or composite core, nor high tip load, nor extra hydrophilicity is needed. In non-CTO cases, frontline cases is considered 70 to 80% of cases. Other cases with special situations are discussed later in details. So wires in the market, which is considered frontline wires, BMW family, soft, light, choice floppy, Renato Pro Water, run-through floppy and extra floppy, cyan and cyan blue. Although cyan and cyan blue wires are with composite core, which is discussed later, it is considered as frontline due to low tip load and low hydrophilicity. Guide wires as Pirate 50 is considered in the gray zone area cases in between the frontline and non-frontline cases with more hydrophilicity and tip load. Other guide wires are not considered due to possible complications and non-needed special characters. How to choose the guide wire? First, what are the available wires? Second, what are the main characteristics and categorization? In these frontline cases, we need a frontline guide wire with low tip load and low hydrophilicity. Then the experience. In this case, BMW soft choice floppy guide wires are available. As you can see, there is no significant difference between the wires in the tip load. Coating is low hydrophilicity or hybrid. Regarding the core material and tip design doesn't differ in this situation. So the PCI was done with more familiar BMW guide wire. In the second case, long CXOM lesion, after Judkin left catheter engagement, choice floppy guide wire was passed in the lesion and parked distally, followed by several balloon dilatations. As said before, it is a frontline Frontline case, the choice of the wire was based on available wires, main characteristics and categorization, and the experience. Yet, the stent failed to pass across the lesion, although several balloon dilatations of the lesion was done. What is the next step? Adding a body guide wire, or changing the guide wire, or changing the guiding catheter, or other techniques to increase support. Parking the choice floppy guide wire more distally, leading to more support, was enough. So a frontline case plan may change into a non-frontline case with addition or changing the guide wire. Yet knowing more details of each guide wire may resolve the situation. With choice floppy guide wire, the distal 3 cm of the tip is radio opaque and with non-hydrophilic coating. The hydrophilic polymer sleeve, not radio opaque, is long, red arrow, and extends from the distal part of the shaft and far beyond the beginning of the tapering of the core. Its length after the core tapering is much longer than the distal non-hydrophilic 30 mm. This long tapering core will lower the rail support and for a long distance. So, a more proximal segment of the shaft will provide more support to balloons or stents. Generally speaking, it is not suitable for distal tight lesion when there is need for support on a long tapering hydrophilic core. Yet, this long polymer sleeve allows tracking long tortuous artery proximal and distal to the lesion. Regarding the guide wire structure, the main component is the core. It is the inner part of the guide wire which extends through the shaft and the tip with a possible transition zone in between. Typically speaking, the tip starts at the beginning of the tapering of the core till the end of the core or beyond it according to the tip type. This includes the transition segment. So it is more than 25 cm plus the distal 3 cm. Yet some authors consider the tip the distal radio opaque segment and or the surrounding coil only segment. This is important when discussing the guide wire support later. Guide wire length, including the shaft and the tip, is usually between 180 and 190 cm. This length allows PCI through femoral or radial access. Guide wire diameter is 0.014 inch. This includes the core and the film of coating. Smaller diameters are used in special situations. This dimension prevents severe angulation within standard 0.014 inch catheter lumens, especially when catheter lumens, including the wire, deform elliptically as the catheters flex in non-acute angles in which the lumen is nearly closed. In all guide wires, the core diameter tapers at the beginning of the tip. Only in some types of the guide wires, as Confianza Pro, the tip, including the core, tapers from 0.014 inch to 0.009 inch. Regarding radio opacity, the distal tip, usually 2 to 3 cm, is usually a radio opaque platinum or tungsten alloy. In some types of guide wires, the distance, radio opaque distance, may extend up to 16 cm. Some radio opacity in the guide wire shaft confirms its passage in the middle of the lumen, thrombus, or stent without kinking bias. Some types of guide wires, as pilot, have a radio opaque gold marker at a 15 mm distance from the distal 30 mm radio opaque segment. It includes a non-radio opaque coil segment, helps in measurements during PCI, and for keeping wire performance and durability, no dilatation is advised over this segment. Regarding the shaft starts from the proximal end till the beginning of the tapering of the core. It consists of core and coating. The core material is usually constructed from solid high tensile stainless steel. This stiff material and its thickness gives stability, steerability, torque, pushability, and support, and trackability to the guide wire from its proximal end to the distal tip. The non-hydrophilic coating allows stability of the guide wire in contact points in the curves in the catheter. No hydrophilicity is needed in the shaft since there is space from the inner wall of the catheter. Some guide wires have a hydrophilic sleeve as polymer extending from the distal part of the shaft, covering part of the tip. This polymer sleeve allows tracking long tortuous artery, proximal and distal to the lesion. In distal lesions, be sure that the balloon or stent is inflated on the shaft, not the tip. As said, in non-hydrophilic, non-tapered stainless steel core will provide better stability and support. In summary, operators should consider developing a feel and skill with few wires that offer different advantages, including a workhorse wire for simple coronal lesions and 2 to 3 guide wires for special situations discussed later. Basic information regarding any wire used should be known to avoid extra cost for safety and high success rate. And this is the end of the video. Thank you for your attention and waiting for your feedback.